Good morning, everyone. Good morning. In the last lecture, I have started with the introduction part. That some basic things were done, like meaning of organic chemistry. Then we have discussed about the structural representations, like expanded form, like condensed form, and bond line notation. These three things we have discussed. Okay? Now, today in the introduction part itself, some other things we will do. Now we will discuss which part. Last class we have done the structural representation. This we have discussed last lecture. Okay. Which notation? Condensed form, expanded form, and the bond line notation. These were completed. Now today's lecture, today we are going to discuss about the terms like degree of carbon and degree of hydrogen. Did we discuss it last class? In last class, did we discuss degree of carbon and hydrogen? Okay, that is done. Okay, fine. So we have discussed the degree of carbon and hydrogen. These two terms completed. Firstly, you want to ask any questions? You want to ask any questions? I have given in the NCERT page numbers I have mentioned. Okay. Ananta. Okay, we have started IUPAC also. Prefix, suffix, root word. Okay, fine. So any questions, mention the page number. Na? If you have solved the NCERT in-text questions, you can mention. If you have a doubt, we can discuss. Any questions you want to ask? Any questions? Confirm, no questions? Here, no comments are there about the questions. So I am starting with the IUPAC. In the IUPAC, sequence we have discussed, that is prefix, root word, and suffix. Prefix, root word, and suffix. How many types of prefix? Two. Secondary, primary. Root word, then primary suffix and secondary suffix. Up to this part we have discussed. Secondary prefix represents branching or substituents in the parent chain. Primary prefix used for the cyclic compounds, and cyclo word is used. Root word represents number of carbon atoms in the parent chain, main chain which we have selected. Then primary prefix indicates carbon chain is saturated or unsaturated, means alkane is there or multiple bond present in the form of alkene or alkyne. And last is secondary suffix which is used for functional group in the parent chain. Okay, up to this part we have discussed. Then write down according to IUPAC or IUPAC, some groups are always treated as prefix. Which prefix? Basically secondary prefix. So as per IUPAC, some groups we always treat them in IUPAC naming as a prefix. Like which one? Which group? Alkyl groups. Alkyl groups like alkyl group, maybe methyl, ethyl, etc. These will be treated as prefix always. If CH3 is not part of parent chain, it will be a prefix. If C2H5 is not a part of parent chain, it will be treated as prefix. So then it is a substituent. Second, halogens. So here it is named as halo groups. It may be fluoro, chloro, bromo, and possibility is iodo. Halogens. Third one is NO2. That is nitro. Fourth one is alkoxy group. Fourth one is alkoxy, which means OCH3, OR can be OC2H5, etc. These are mainly used in the examples. When you read the materials or books, then you will get more substituents, but they are not mentioned in the NCERT or NCERT exemplar, so they are not relevant with the syllabus. Most relevant are these four: alkyl group, halogens, halo groups, nitro, and ethers, which is OR alkoxy group. So as per IUPAC nomenclature, they are always treated as prefix. In nomenclature, we will treat them as substituents or prefix. Written, can I change the slide? Now, in the NCERT, it is given here. After prefix, we talk about the root word. Okay? In root word, you all know that one carbon means meth, eth, then prop in this manner. So with the NCERT, you can underline that one. This too you all know. Which are separately you should know: this one. If it is given in the match the following type, then you have to answer. Remaining to we all remember. Icosane C20, CnH2n plus 2, H42. Triacontane C30, H62. So whichever given in the NCERT, that is important for us. Remaining easily we can say icosane and triacontane, that you can mark in your NCERT also. Then you can mention root word, myth, ith, prop, but, pent, hex, hept, oct, nth in the IUPAC of periodic table we use, it is non-deck. Undeck, two deck, like this. So this is the root word use. One carbon is present in the parent chain, myth. Then if two carbons present in the parent chain, ith, and same pattern we will follow. Mostly you get the questions within 10, mostly. Beyond it, not useful, so only mark in NCERT wherever something is given. ठीक है, myth, ith, prop, but, pent, hex, hept, oct, non, deck, undeck, dudeck, trideck, etc. This is about root word. Now, after that we will talk about the, I'm giving you option I'm giving you functional groups or secondary suffix. There is a list of the seniority order of functional groups that I will discuss with you first, or else I discuss with you the common naming like iso, neo, secondary, tertiary, etc. Which you want, it's up to you. Shall I discuss the suffixes, means seniority order, or shall I discuss with you this part of NCERT? Tell. Common naming I tell, or suffix first, seniority order? You tell. Introduction class it is. It is your discussion, it's your part, because in regular class so I will go straight forward with the sequence. Today introduction class it is also. Suffixes. Okay, out of these 5 students are saying that. Root word, so that is the only root word. Root word means number of carbon atoms in the parent chain. So that is so already completed. Iso, neo, common naming, or suffixes, seniority order. This one. most of the students here saying seniority order, functional groups. ठीक है. After this, I can talk about the common naming. Ultimately, we will do. My point is, which you want first introduction class it is. So we will talk about suffixes now. Now, in the suffixes, as per IUPAC, ठीक है? As per the IUPAC, it is seniority order given here that when the parent chain is selected, we select the chain which should contain the functional group. ठीक है? Which should contain the functional group. If multiple functional groups are there, then out of them, one has to be the senior functional group, which is secondary suffix. Other functional group becomes a prefix. So that learning has to be required for the seniority order. Clear? Then only polyfunctional group questions we can solve. So in the suffixes, secondary suffix, it is the decreasing order of the priority of the some functional groups. It is given by IUPAC as per the IUPAC convention, which is number 1 here. It is carboxylic acid. So here you can mention in the notes suffix, secondary suffix में you can mention seniority order. Seniority order of the functional groups in decreasing order. First is which group? Carboxylic acid. ठीक है? Then after that sulfonic acid. Then it is anhydride. In NCERT, anhydride not given, so you can add here anhydride, then ester. Anhydride, then ester, then acid halides X. Generally we use halogen Cl, otherwise COX, acid halide or acyl halide. Then acid amide, then cyanide, aldehyde, ketone, alcohol, thiol, amine. Thiol not required in NCERT, nowhere given. Nowhere given. Anhydride is separately not given in the IUPAC, but its example is given in the carboxylic acid. So that's why little bit idea only, not details of anhydrides, not complicated example, just to know how to write the IUPAC name of anhydride. It is the seniority order. Carboxylic acid, sulfonic acid, acid anhydride, ester, acid halide or acyl chloride, acid amide or amide, cyanide, aldehyde, ketone, alcohol, NH2. Isocyanide nowhere in the naming we use. So in the materials you might get other groups, but that is irrelevant. Whichever unnecessary, why to learn the information which are not useful as per the NEET level or NCERT. So if the carbon chain contains the functional group, so polyfunctional group, 2 functional groups are there or 3, we use this seniority order, which is senior in the functional group will be acting as suffix, remaining all functional groups will be a prefix. So that is the use of this seniority order. ठीक है, names required I should write or you are able to identify? I have repeated them three times. Are you able to identify the functional groups? Okay. ठीक है, I'm writing. You are saying required. One student saying not required. Other saying yes. ठीक है, I'm writing the names also here. This is carboxylic acid, sulfonic acid. Ester, C double bond O O R. Actually, here it is halogen Cl or Br possible acid halide. So I have written general term acid halide here. So here also I am writing acid halide, or acid halide, or you can say acid chloride, which is written above. For this particularly I have written COCl. Okay. Rocky. NEET coming out of NCERT, no need to solve. Whichever you see in NEET levels, understand one thing. If any one question is going outside the NCERT, no need to solve. Understand one thing. Nowadays, NTA purely going by NCERT. So no need to waste time in learning excess of information, which you might find interesting. You might feel that, oh, it is something special, and NCERT is not giving it, it is not special for us. So important is what not to study also. This is amide, cyanide. ठीक है. Next is aldehyde CHO, ketone, alcohol, amine. ठीक है. This is the name of the groups which we are going to use. Among them, most commonly used are carboxylic. Most commonly carboxylic is there, aldehyde, ketones frequently, and this. Yes, these are more important. Others we will do, but depending upon their importance, we have to focus, because in NCERT you will get chapter on alcohol phenol ethers. Questions are directly given in the IUPAC of each chapter. Amine is given, aldehyde, ketones, and carboxylic acid given. And remaining maybe in between it will come, so that we will solve. But I said which is important, that I have marked. ठीक है, written that one. Yeah, aldehyde, ketones or carbonyl compounds, these are separately given in the class 12th. ठीक है, I am changing the slide now. So firstly we talk about the common names or common naming. Common naming is useful in the reactions. Sometimes in the reaction directly they are writing common name, like isobutane, like sec-butyl chloride. That time you should be able to write the structure from the name given. That's why it is important. So in common naming, first is normal compounds. be represented by N compounds like N-pentane, like N-pentane. Now, N compound means normal, and normal structure means linear structure. Normal means linear structure, which contains primary carbon, secondary, but no tertiary, no quaternary carbon. So N compound you will understand by which way? Straight chain of carbon, that's it. So normal compound contains what? Primary and secondary possibilities, secondary there but no tertiary and quaternary. So N-pentane means you will write this term. That's it, completed. Only straight chain or linear chain of the carbon. This is normal or N compound. If it is N-hexane, common name it is. So you will write N-hexane, linear chain of 6 carbons. Getting it? That is the meaning of N compound, but it is common name. If I say pentane, so pentane is IUPAC name, but N-pentane means common name. N indicates normal, straight chain. So it consists of primary and secondary carbons, but no tertiary or quaternary. Then if it is N-propyl alcohol, so if any group is connected, then that functional group will be connected to primary carbon only, not secondary carbon. Like N-propyl alcohol, so you will write it like this: CH3, CH2, and then CH2 with OH. So whatever group is connected, it will be bonded to primary carbon. That's why any side you can write OH here or there, same. N-propyl alcohol. N-pentyl bromide. Whatever group, write the straight chain, and with the terminal carbon primary, you will connect the Br. So write down the structure of N-pentyl bromide, N-butyl chloride. N means normal. Written, I am writing it. Before I write, your answer should be there in your notebook. This is 5 carbon straight chain. On the terminal carbon, Br group is there. This is N-pentyl bromide. Then N-butyl straight chain of 4. On the terminal carbon, which is bonded, Cl, that's it. So these are important. Why? Because of the reactions. Usage limited, propyl, butyl, pentyl maximum. You will not get any bulky questions on these common names ever. Written, ठीक है? Now I'm changing the slide. After the N compound, next are the iso compounds. Next is iso. Iso indication is, iso arrangement is like this. Again, their significance is 3 to 5 carbons only. You will not get examples beyond that. This type of arrangement is isoalkyl group. It is which representation? Isoalkyl means in the straight chain on the second carbon you will get one methyl. In the straight chain on the second carbon, any side, it is methyl connected. It is iso. Their significance is 3 to 5, 6 like this. 6b only you will not get, maximum 3 to 4, 5 only. So example I'll give you understand better. If it is isobutane. Isobutane. So you will write firstly this arrangement: CH3 CH3. ठीक है? Then further bond you can increase the carbon chain depending upon the question. In the question, but is given. But means 4 carbon. So here how many carbon completed? 3. So you will write 1 carbon only like this, and this becomes total 4 carbon. In the straight chain on second carbon there is methyl group. It is isobutane. Iso, total carbon 4, butane. Now you can try next one, isopentane. Try to write it. Isobutyl chloride. I hope you are getting the meaning of these terms, which are very relevant with the syllabus in different chapters. And we will do the relevant examples only, no unnecessary bulky examples. ठीक है? Isopentane में firstly you will write with structure iso like this. How many carbons? 3 over. How many left? 2. Further increase carbon chain CH2 CH3. In the notes you can write with hydrogen, completing the valency. Here I have written only the carbon skeleton. CH3 CH CH3 CH2 CH3. ठीक है? Then whatever functional group is there, connect it to primary carbon. Just like in N compounds we have done, connect it to primary carbon. Here isobutyl. So firstly write down the arrangement of iso. Fix it. Fixed. Now chlorine. You will attach to primary carbon here. CH2 and then Cl. This is iso. 4 carbon completed but, and whatever group is given, halogen or functional groups given, it will be bonded to primary carbon in this manner. Clear? Done. Next isopentyl, try in a similar way. Done. Very good, Ramya. Isopentyl, I'll fix this arrangement. It is iso. 3 completed. In pentyl 5. Out of 5, 3 done. 2 left. Add 2 here. Isopentane. Alcohol group bonded to which side? You can connect further here. CH2OH. Keep this as it is fixed. Iso. And then keep on increasing the carbon chain. On the primary carbon, you will attach whatever group is mentioned. So this is the meaning of iso group. In iso group, if you observe, primary carbon is there, yes. Secondary possible, yes, with carbon chain increase. Tertiary only 1. Tertiary only 1 and no quaternary carbon. Some variation you will get in isopropyl. Like in isopropyl, already 3 carbons are there only. And iso group is also 3 carbons. So CH3, CH, CH3. Iso completed. Now which group? OH. So it will be bonded only to middle carbon. That is secondary carbon. In other cases, more carbon atoms, whatever group is there, it will be bonded to primary. But in isopropyl, there is no possibility. So it will be write down the iso arrangement and directly connect OH to the carbon where connectivity is there. Try next one also, isopropyl bromide. isopropyl bromide, I'll write CH3, CH3 arrangement, and then prop completed, Br will be bonded to secondary carbon only. Clear this example? How to write the structure if in the reaction what is given? Iso and N compounds, because for nomenclature it is less important, but for the reactions it is very important. IUPAC questions are, or IUPAC topic, generally students take it lightly. Reason, they think that okay, in the exam one question will be there and so many things I have to learn. But remember, in the reactions, what happens sometimes, directly names are given rather writing the structure. Then that time you have to write the structure and then you will do what? Completing the reaction. Other possibility, in options, rather giving the structure of the reaction, they give the which part? IUPAC name. That's why do not take IUPAC nomenclature lightly. Okay? This is ISO. Next one is, after ISO, next frequently used is neo compounds. In neo compounds, this is the arrangement. This is the arrangement for neo-alkyl group, in which only one quaternary carbon, in which only one quaternary carbon, and this is there surrounded by carbon atoms primary. This is CH2 which can be further bonded. So minimum possibility with neo is 5 carbon, minimum. 1, 2, 3, 4, 5. Minimum possibility will be 5 carbon for neo. Minimum 5 carbons are required. So basic example, first one, neopentane. Third is neopentyl chloride. Common names. Neopentane, this connectivity first. CH3, CH3, CH3 and CH3 only. Why? 5 carbon completed. This is neopentane arrangement. Neohexane, same way. Write down neohexane. Then write down neopentyl chloride. Structure, whatever group it is bonded with the CH2 carbon. Try to write both of them. Neohexane will be like this one. I'm writing bond line. Bond line will be, this is neo. CH3, 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 carbon, CH2, CH3. Bond line. Neopentyl, bond line. Done. Next one, neopentyl alcohol, bond line. Here, alcohol OH. Done. Then after neo, next which is used in the reaction sometimes is secondary compound sec. For neohexane, 6 carbon, 1, 2, 3, 4, 5, 6. Clear up to this point? Next one, secondary compounds. Secondary compound में you will get only one example always, that is sec with butyl. Sec butyl alcohol, suppose. As the name it is, sec means secondary. So alcohol will be bonded to secondary carbon, that's it. That is the significance of sec compound, and generally you will get with butyl, generally. Beyond it you will not get. So when you write the structure CH3CH, CH2, CH, any side CH2, it is secondary carbon. With secondary carbon you will get here OH group. This is the meaning of sec butyl alcohol. So whatever group that will be bonded to secondary carbon, that's the significance. Beyond it, no such example is given there in the NCERT. So that is the point, sec butyl alcohol, sec butyl chloride, that's the significance. Same with tertiary compounds. Tertiary compounds में whatever group is there, it will be bonded to tertiary carbon, tertiary butyl bromide. So structure will be, write down the 4 carbon with 1 tertiary carbon there. This is tertiary carbon which is bonded to 3 other carbons. It is tertiary carbon bonded to 3 other, and on this carbon which will be there, bromide. So you will write on tertiary carbon bromide. That is the meaning of which compound? Tertiary compounds. Similarly, tertiary butyl alcohol frequently used in the reactions of alcohol phenol ethers chapter. Again, if I write bond line notation will be in this manner. Check. Clear this one? That is the significance of tertiary compounds. You might get tertiary butyl bromide or alcohol, or I can say tertiary pentyl alcohol. Tertiary means whatever group is there, it will be bonded to tertiary carbon. So structure will be, firstly draw tertiary carbon, 4 carbon completed. Then add 1 more carbon, it is generated. With tertiary carbon which is bonded now, OH. This is tertiary pentyl alcohol. So that is the meaning of common names like N compounds given, iso compounds given, sec compounds given, neo compound given, and tertiary compound. So that is very useful, not for the naming purpose, but for writing the structures in the reaction. ठीक है? This is second introduction class, then Khurshi Raju. It is secondary class. Then on third onwards, we will start with the actual detailing of the chapter. Till now, though, we have done only introduction, some common names like this. Okay. Any questions you want to ask up to this? Up to the common names. Any questions from your side? Syllabus is reduced as per CBSE. रोसम्मा, ठीक है, as per CBSE syllabus is reduced, but yet it is not updated for NEET. Clear? ठीक है. Any other question up to the common naming? ठीक है, चलो. Now in the NCERT, we'll again go for NCERT part. Now, before starting the actual IUPAC, some other terms which are given, like what's the meaning of functional group? Understand it only, no need to write anything. Okay, no need to write anything. Understand it's a part of NCERT. We'll read everything of NCERT. Functional group is what? It is a group of atoms, or it's an atom also possible, that largely defines the chemical behavior or chemical properties of a molecule. So here it is given definition of functional group, which largely decides the chemical properties of the organic compound. Like alcohol, OH group is there, it will give the chemical behavior or chemical reactions of alcohol, or carboxylic acid or aldehyde. Then this term also you all know what's the meaning of homologs or homologous series. Read it from your book, you can read that what's the meaning of homologous series. Read it fast, you have the NCERT with you, so from your NCERT also you can read it. ठीक है, I hope by this time you have read it. Yeah, Swaroop, it is by CBSE next time. So in homologous series, what is the key point? It is a series of the compounds which have the same functional group, same general formula. Okay, same functional group, same general formula, and each consecutive member differ by CH2 group. Each consecutive member differ by CH2 group or CH2 unit. Basic example: methane, ethane, propane, butane, or ethene, then propene, then butene. So each consecutive member of alkene differ by CH2 unit. This continuation of the series is termed as homologous series, and each member with respect to each other is a homolog. Like methane homolog of ethane, ethane homolog of propane, butane homolog of propane or pentane. So that is the meaning. Homologs show similar chemical behavior. Homologs show similar chemical behavior, but they differ in something. Can you tell? Can you tell they differ by which thing? They have similar chemical behavior, but they have different. Any point you know from the junior classes? Homologs. Yes, Praneeth, it will be by CBSE. Okay, one difference already written by, they differ each other by CH2 unit. Apart from that, can we say they have similar chemical properties and they have similar physical properties also? or difference arises? Tell. Or can we say both chemical and physical properties are same? Very good. Different, okay. Question is, these homologs have similar chemical behavior, na? So can we say they have also similar physical behavior? Very good. Generally, chemical properties same or almost similar, but physical properties differ. Why? As the number of carbon atom increases, there is regular increase in the boiling point and melting point. So there will be always increase in the physical properties like melting point, boiling point, etc. That's why I said these are the terms which are related to mainly junior classes. So you can recall very fast. ठीक है? Then on previous page, one representation is given, which is this one, three-dimensional representation. Given now, this is wedge and dash representation. So generally we use this in the optical isomerism. In the reaction in NCRT, we never use wedge dash representation, but it will be useful for optical isomerism. Beyond it, in the reactions, we never use. This is CH4 molecule. This is in the dark. This is wedge. Wedge, non-wedge, nahi. Wedge, which is in the dark written, and it is considered to be above the plane. It is considered to be coming out of the plane, and dash is given there, which means it is below the plane, away from you. And which are normal bonds, they are considered to be in the plane. So if I am discussing here in the board and you are having the NCRT book at home, so these two hydrogens which are normally bonded, they are in the plane of the board. Another hydrogen which is on wedge, it is above the plane of the board, and dash hydrogen is below the plane of the board. That is the meaning of wedge and dash representation. Clear? When you read that story also, above the plane or towards the observer, dash means below the plane or away from the observer. And normal bonds, they are in the plane of the board or paper with carbon. So here, if I write this compound, so this is what center point carbon. These are normal bonds. They are in the plane of the board. ठीक है? Cl on wedge. This is above the plane of the board or towards the observer. And this is dash. This is dash, which is fluorine is below the plane of the board or it is away from the observer. That is the meaning of wedge dash representation. ठीक है? So when you read NCRT, you will understand that paragraph which is given. Yes, fluorine on dash means it is below the plane, Cl above the plane, outside of the board coming out, and these two, bromine, iodine, are in the plane. Then here what is given? Ball and stick model. You can read that portion for your reading purpose only. In this molecular model, they have given these three types. When you read here initially, three types of molecular models given. Three types of molecular models are given. Like these are given for these are given here. Space filling model. Now, in the framework model, only bonds connecting to the atoms, like this one, it is shown. And atoms are not shown here. It is which model given? Framework. Space filling model. It is third one. Second one is ball and stick model. In ball and stick model, what is given? In ball and stick model, both the atoms and the bonds are shown like this. And bonds are also shown. If it is bonds are shown only, it is which model? Framework. If this one, sticks are means bonds are shown and atoms are shown, it is ball and stick model. And other one is space filling model. Space filling model emphasizes on the relative size of the each atom based on which factor? Van der Waals radius. So these type of theoretical points may be useful for which thing? Class level basic questions. NEET level chances are less for this. Given here, so we will still read it. That is our habit. Okay, so here is space filling model emphasized on the relative size of each atom depending upon their van der Waals radius. Bonds separately we are not going to show, and this is given here. Okay, so this thing is the general representation of the structure actually, practically. Then initially on this page, if you have gone through, have you solved these questions? All questions solved, 12.4, 12.6, 12.5. Completed those questions? Any doubts in any of the structure? In these questions you want to ask? Any questions here? Any doubts you want to ask? Fine. Now it is audible. So here what happens in this, the carbon chain is, carbon can be all three, sp, sp2, sp3. So this means that it will affect the electronegativity of the carbon. Why? Because carbon which is sp hybridized will be most electronegative among them. So when you read that portion, you will get the idea. Hybridization, it influences bond enthalpy as well as bond strength. Generally, we say stronger is the bond, shorter will be the bond, or bond length inversely proportional to bond strength. General term. Exceptions possible? Yes, possible. Then, how the change in hybridization affects the electronegativity of the carbon. Greater the S character, greater is the electronegativity. Means as percentage S character increases, electrons are more tightly bound to the nucleus, more attraction, and hence electronegativity increases. So as percentage S character increases, electronegativity of carbon also increases. It also forms stronger bonds, hence bond length decreases. Then what is given after this hybridization explanation? It is given here, example 12.1, sigma and pi bonds. I think that most of you know that between two atoms, when we say first bond is sigma, then further bond formed between the two atoms, it is pi. So here in these questions, you have to count sigma and pi bonds in these questions. Like first one. In the first one, if you observe, this is given. Between carbon hydrogen, one sigma bond. Because between two atoms, one first bond is sigma. Head-on overlap takes place. Even if you do not remember overlap, still one bond you understand, it is sigma. Now between two atoms, three bonds. So one is sigma, remaining pi. So here three bonds, one sigma, two pi. Then CH, sigma bond. Then double bond, one sigma, other has to be pi. Then C, again sigma, and three hydrogens, all sigma. So if I want to write it, this structure, it will be CH3, C triple bond, C, CH double bond, CH single bond, CH. Suppose this is the structure, suppose. So you will count it by writing the structure, expanded form. Better it is CH3, C triple bond, C, CH double bond, C. So now you can count the sigma and pi bonds. So here 1, 2, 3, sigma bond counting, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for this compound, sigma bonds 13, pi bonds, 1 sigma, 2 pi here, 2 pi. Here also 1 sigma, then other one is pi, 3 pi bonds. So this is the part which is given there, counting number of sigma and pi bonds. 13 sigma and 3 pi bonds. Similarly, other example directly you might find correctly, that is here B. In this case, CH2, 2 sigma. Then here 3 sigma, 4 sigma, 5, 6 plus 3, 9. 9 sigma here present. In B, there are 9 sigma. And pi, how many? Here pi 1, there pi 1, 2 pi bonds are there. Clear? Getting it? You will write the expanded form of this compound. Getting the answer for B, how many sigma pi bonds are present? For B, 2, 3, 4, 5, 6 plus 3, 9. So total 9 sigma bonds. Here they have given it like this. CC how many? 3 sigma. CH how many? 6. 6 plus 3, 9. And other pi, 1 pi there, 1 pi there. That is how these type of questions are relevant with the syllabus. If you go through previous year questions, these questions are given there also. Structure given, find out number of sigma and pi bonds. That is a relevant question. Then you can try remaining questions like this: carbon hybridization. If carbon is all single bond, sp3. If carbon has 1 pi bond, sp2. If carbon has 2 pi bonds, it will be sp hybridized. Okay? So that is the part which I can say it's a basically introduction, hybridization general point, then structural representation, and then we can say some common naming, including suffix, prefix and root word, including which groups are always prefix, including decreasing order of the functional groups. Clear? ठीक है चलो. So in the next class, it will be our proper course planning will start with that. Be ready with that. Keep your notes with you. Keep your rough notebook with you also, so that any question I am writing, you have to solve it. In practice notebook, you can try also. So everything will be pretty simple, very easy things, but you have to do these things regularly. Writing the notes neat and clean, reading the NCERT, solving the NCERT questions. When modules are available, that will be informed by as early as possible. So everything will be very cut to cut, very systematically we have to go for it. Only thing is you are in online mode, so you have to be following very highly disciplined schedule at home. No distraction, no wasting time on mobile or social media. Okay, done for the day. So see you soon. In the next class, we'll meet. Take good care of yourself. Bye.